Hi guys, we are now in our second unit. We are going to be let's see if I can get my drawing tool to work. We are in unit 2 and we are in notes packet 1, okay? And I want you to go ahead and I want you to move to page 6. We are going to be talking about square roots today, okay? So if you could page down, and we are on page number 6, okay? So we will start at the top. Like I said, this is lesson 7.1 from your textbook. So if you need help, you should go there for your resource. Okay, and we're going to talk about square roots. The definition of a square root is a number when multiplied by itself equals the given number. Okay, so a number when multiplied by itself equals the given number. An example would be the square root of, let's say, 169. Okay, and that is 13 times 13, which equals 169. Or you could have negative 13 times negative 13, and that also gives you 169. Okay, so again, the square root is a number that when multiplied by itself equals the given number. Okay, if you have the symbol, you guys have probably seen this before, the square root symbol. That little, we call it a house, right, is called the radical sign. Okay, and the number that we put underneath of it is the radicand. Let's see if I can spell this today. There we go. Okay, and the types, I'm going to put positive, and I'm going to put positive or negative. Okay, so we could have something like the square root of 144. Okay, and you are going to need to memorize these. The square root of 144 is 12, and that's because 12 times 12 equals 144. So they're opposites of each other. Okay, you could have, I could say, the positive or negative square root of 36. Well, I hope you know the square root of 36 is 6, but it could be a positive or a negative, and that's because 6 times 6 equals 36, but negative 6 times negative 6 also equals 36. Okay, if I ask you to find the negative square root of 36, then your answer is just going to be negative 6. Okay, so that's kind of how we do that. In turn, let's go down a little bit if we're talking about perfect squares. Okay, the definition is a number with integer roots. Okay, a number with integer roots. What does that mean? Integer? That basically means no fractions, and it means no decimals. Okay, no fractions, no decimals. Just talking about integers here. So an example would be 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, etc. Okay? The symbol, we just do 5 with a little exponent, and that equals 125. And 125 is actually your perfect square. Okay? Your perfect square. A number with integer roots, okay? We won't talk about types, that's not really relevant. And then it says find the 2 square roots of 16. Okay, like we talked about above, when we're talking about the 2 square roots, you are going to be talking about plus or minus the square root of 16. So that's going to give you a positive 4 or a negative 4. And if you think about it, it's because 4 times 4 equals 16, and negative 4 times negative 4 equals 16. So you could get either one, okay? And then if we look at the bottom here, what is the relationship between finding the square of a number and finding the square root? Okay, well, they are, let's see, they're inverses of each other, okay? Just like we have addition and subtraction are inverses of each other, and what we have multiplication and division are inverses of each other. A number squared and its square root are inverses of each other also, okay? If we keep moving right along, before I go any further, Make sure that you have that yellow sheet of square roots and cube roots filled out. If you need to have your calculator to do it, that's fine at first to make sure they're accurate, but we will have to have those committed to memory, okay? Moving right along, we're on page 7. I ask you to find two, okay? So we're finding 2 square roots of the given number. So I'm going to rewrite that as plus or minus the square root of 64. Okay, at first I'd always have that yellow sheet out until you have it memorized. I hope you know the square root of 64. What number times itself equals 64? Well, that's 8, and it's plus or minus because I want both of them. Okay, the square root of 1. 1 times 1 is 1, so the answer is just a plus or minus 1. And then I want to find the 2 square roots of the given number for 169. Well, the square root of 169, I hope you know, is 13, and it's positive or negative. So there's my answers, okay? Now it says evaluate the following expressions, show your work as needed in space provided, and circle your final answer. We're going to skip around a little bit. We don't need to do each of them. Okay, on number 2A, if there is not a positive or negative in front, it means it just wants the positive square root. So the positive square root of 81 is, let's go to a different color here, mix it up, is 9, okay? The negative square root of 36, negative 6. Okay, here we have positive or negative square root of 9 over 100. Okay, it's the square root is over the entire thing. So if you would like to rewrite it like this, if it helps you, square root of, what was that, 100? Okay, so we know we're finding the positive and the negative. The square root of 9 is 3, and the square root of 100 is 10. Again, guys, you just have to have that yellow sheet memorized. Okay, now, 2D becomes a little more difficult, and it's difficult because it has a decimal point. So what I do is I first take away the decimal. Take away. I mean, some of you will be able to see it right away, and that's fine, but if you don't, take it away. And we're talking about the square root of 484, okay? Once you have these memorized, you're going to know that the square root of 484 is 22. 22 times 22 is 484. Now, how I like to think of it is now I need to put my decimal place back in, okay? And you can see here that we have 2 decimal places, okay? So that's going to be, just writing that here, 22, 22, and we have 2.2, 2.2. Why is that? Because you add decimal places when you multiply, so it's obviously going to go in the middle. So I'm going to have 2.2 as my answer. If you want to test me and see if Quinto's made a mistake, you always can. We're going to do this. Let's see if I can get it out a little bit. Let me see if it lets me right here. If I do, oh, it won't. Okay, so let's go right here. If we do 2.2 times 2.2, let's test Mrs. Quintos out. Got a 0, 4, 4, 4, 8, 4. We have 1 decimal place, 2 decimal places. So we go over 2, 4.84. See if we get back there. So I was correct, okay? What else do I want to do? Let's make this a little bit bigger so we can actually see it. Okay, let's look at 2E, if you will. Okay, again, I'm going to change it to negative square root of 169. Take out that decimal place. I know the square root of the negative square root of 169 is negative 13. Okay, and then I'm going to add my decimal place back. I'm going to, so 1.3 times 1.3 is going to give me 1.69. Okay, let's do just a couple of more. Okay, let's look at this. Actually, let's not. We'll leave that for you. Let's go over to 2G. Now, there's a big difference between something that looks like this with a negative on the outside and something like this that has a negative on the inside. Okay? When you have a negative under a square root, there's no real solution. Okay? And the reason for that is there is no number times itself that equals negative 100. 10 times 10 equals 100. Negative 10 times negative 10 equals 100. So you're not going to have a number times itself that ever equals negative 100. So whenever you have that negative under the square root sign, you're going to say, nope, no real solution. Okay? Let's flip down to, let's see what else we got here. So there's another one, right, with a no real solution I can see down here. Let's look at, see if there's a good one here. Okay, I want to go over to 2L, okay? And the reason I want to come over to 2L is because, let me get my tool out here. 12 is not a perfect square, and 75 is not a perfect square, okay? When you see a problem like this, I right away think, oh my goodness, that does look like I can simplify because I can see that 12 and 75 are both divisible by 3. So I literally, when I have a problem, if Mrs. Quintos gives you a problem and you're thinking, well, that's not a perfect square, look and see if you can simplify it first. Okay, we're going to divide by 3. We're going to divide by 3. That gives me 4. And what? That gives me 25. Now I have the positive or negative square root of 4 over 25 because I simplified it. Okay, and like I said before, you can do positive or negative square root of 4 over square root of 25 because it's the square root over everything. Okay, the square root of 4 is 2. The square root of 25 is 5. And there's your answer. Okay, let's go ahead and let's move on to page 8. Okay, I don't want to make this video too long. So those problems on that page before should be relatively easy once you get that yellow sheet memorized. Now I want you to actually evaluate expressions, okay, where you have to do a little bit of math. So here, if we look at, just look in here, let's look at 3a. We have 2 times the square root of 144 minus 30 minus 6. Okay, I kind of take care of those square roots first. It's kind of like simplifying, right? What's the square root of 144? Well, it is 12. Okay, and that's 2 times the square root of 144. Just like when you have a variable and its coefficient squished together for multiplication, same thing applies here. That's multiplication. Minus 30 minus 6. Okay, order of operations, we do multiplication first. We've got 24 minus 30 minus 6. 24 minus 30 is negative 6. Minus 6 is going to give me negative 12 as an answer. Okay. Let's see what we got here. Okay, the square root of 36 over 4 plus 1/6. Now, some of you might recognize right away that the square root of 36 is 6 and the square root of 4 is 2. I also see that 36 is divisible by 4. 36 over 4, well, 36 divided by 4 is 9. So I've got the square root of 9 plus 1/6. The square root of 9 is 3 plus 1/6. Oopsie. I get 3 and 1/6. Now, if you didn't notice those were divisible, it would still work. You could do 36 over square root of 4. You're going to get 6 over 2, which is going to give you 3. And either way is going to give you the right answer, okay? Moving on to 3C. Okay, whenever you see a square root symbol and then it's squared, I want you to recognize that those are opposites, okay? And they kind of cancel each other out, okay? So you could literally just go 45 minus 16. Now, why in the world does that work? I want you guys to know why. So wait, 45 minus 16 is 29. Okay, you can do the math. But why does that work? So why does this work? That's the big question. Well, let's think about it for a second. If I take the square root of 16, let's just do this. 45 minus the square root of 16 times the square root of 16. Okay? 16 times 16 is 256. Okay? The square root of 256 is 16. Look at that. Oopsie. It would help if I 45 minus 16. Okay? And then you just have the same problem. We're back to square one, 29. So either way works. But for purposes of our class, we can just say, oh, they're opposite and cancel them out and leave it at 16. Okay? Which means the same thing over here, right? In 3D, square root of 196 squared. Those are opposites. And we're literally going to cancel them out. And we're going to say our answer is 196. Okay? Which is pretty simple once you get the hang of it. Okay, moving right along, we're going to go down to some applications. What is the radius of the circle? Use 3.14 for pi. Show work, blah, blah, blah. Okay, so what we're going to do is we are going to go ahead and we are going to figure this out. What is the radius of the circle? Well, I hope you remember from your time with Mr. Robert and Mr. Harris that the area of a circle is pi r squared. Okay, what do they give us in this problem? Well, they give us an area of 50.24. Okay, equals, they told me in this problem to go ahead and make pi 3.14 times r squared. Okay, now we're going to solve this. Now I hope you see that those are squished together, so that means multiplication. I am going to divide by 3.14, okay, and I am going to get, let's see, 50.24. I am going to use my calculator. It says not to, but in the interest of time, I'm going to do that, and you get an even 16. So r squared, those cancel. R squared equals 16. If I take the square root of both of those, because how you undo, remember I talked about on the first page, inverse operations. How you undo squared is take the square root. So r equals 4 for that problem. Okay, moving right along, we don't need to do both of these. Which one do I like better? We'll do the first one. Okay, area equals 324. We have an S and we have an S. Okay, we've got S and we've got S. We know side squared, or side times side, is the area of a square. So side squared equals 324. And how do we undo squared? We take the square root. So the square root of 324, and you guys are going to have your yellow sheet next to you until you memorize those, is 18 centimeters. Oh, and up here I should have had inches, right? Okay, let's go to our last page. We are in the home stretch. Okay, I'm going to go to page 9. And let's see. Let's do this one in the corner here. We've got the area is 2.89 and we have another square. So we're going to take side squared, because side times side equals the area of a square, 2.89. Okay, you undo your squared by taking the square root. The side equals, okay, so I know, if you don't realize, 289, the square root of 289 is 17, and then I'm going to add back in that decimal point, and we've got inches here. Okay, and oh goodness, we are definitely in the home stretch here. It says find the radius of each circle. Show your work in the space below. Well, the good news is that they gave us the area, okay? We know its area. And we know from the previous page and from last year that the area of a circle is pi r squared. Okay, so now I'm going to plug in pi. It says my area equals pi. So pi equals pi r squared. Okay, we got a lot of multiplication going on here. Let's divide by pi on both sides, because look what happens. Those cancel, I'm left with r squared. Pi over pi is 1. Okay, oopsie. Oh, I don't know what's going on here. There we go. Okay, to undo squared, we take the square root. So r equals 1. That's supposed to be a 1. And we got yards. Okay, and let's do one more. Let's do this one, okay? If we've got area equals pi r squared, okay, here we have 9/16 pi is my area. Okay, so we've got area equals pi r squared. We've got 9/16 pi equals pi r squared. I'm going to divide both sides by pi. Why? Well, because this is multiplication and we know that division is the inverse. Okay, I've got 9/16 equals r squared. And now we're golden, right? The inverse of squaring something is taking the square root. Okay, the square root of 9 is 3. The square root of 16 is 4. And our label is meters. And there you have it. I think that is plenty for today. You can go ahead and start your homework. And we will talk about this